Now, to fill out the rest of this chart and continue to analyze the information on the periodic table, we have to learn about a chemical concept called the isotope. The isotope. And I'm going to bring us to some information that's found on a website called njctl.org. This is out of their presentation, slide 81 of one of their versions of their presentation. And it says atoms of the same element can have different numbers of neutrons. So we learned that all of the atoms of an element have the same number of protons. However, they can have different numbers of neutrons. And that's why, again, we define an element by its number of protons. So the same element, if you have atoms of the same element, they can have different numbers of neutrons, which makes sense because the neutrons, they give mass to the atom, but they don't give a charge to the atom. So it's the charge that generally determines an element's chemical properties. So here it says, for example, some carbon atoms have 6 neutrons. Some carbon atoms have 8 neutrons. Atoms of the same element that have differing numbers of neutrons are called isotopes. So this is the definition of an isotope, an excellent definition of an isotope. And note, isotopes of an element will always have the same number of protons, but differing masses due to the differing numbers of neutrons. And if we go to another very important slide in this presentation, it talks about, and it gives a really good summary of each one of the subatomic particles and what it contributes to the atom. We look here. The proton is contributing a positive charge and approximately 1 atomic mass unit, or AMU, of mass to the atom. The neutron does not contribute charge and therefore is really not very important most of the time for the atom's chemical properties. However, it does contribute 1 AMU, or atomic mass unit, of mass. The electron is extremely small compared to the neutron and the proton. Therefore, it really does not provide much mass to the atom. 1 out of 184, 1,840th of an AMU. So that's extremely small in terms of its mass compared to the neutron and the proton. But what the electron does provide for the atom is the negative charge, and therefore is extremely important in terms of the element's chemical reactivity and properties. So that is the definition of an isotope. Now, in terms of writing isotopes, this is extremely important. How do we represent these isotopes? Let's say I have neon. And I have neon, and if we look in our periodic table, neon, which is in group 18, neon has an atomic number of 10, and its average atomic mass is 20.179. But let's say we have a single atom of neon, and that atom of neon has a mass of 20. Okay, so it has a mass of 20. So the neon 20 can be represented in 4 different ways. You could say it's neon dash 20 because we know it has 10 protons, right? So all the neon in the world has 10 protons, so we don't have to say anything about the atomic number. We could just say this is neon 20. You could also use the chemical symbol, Ne. You could also write it as 20. Actually, it would be the 20 would be on the top in the isotope notation. Or you can put the atomic number and the isotope notation The atomic number would be on the bottom, and then the 20 would be on the top. So this is a bit confusing because if you look at your periodic table, we have the atomic number on the top and the atomic mass on the bottom. Here in our isotope notation, we have the atomic number on the bottom and the mass of the isotope on the top. It's just a convention in chemistry to write isotope masses that way, which is the reverse of what you see on the periodic table. Just remember, this is the mass of the isotope. Okay. And the other way to remember that is that the larger number is the mass of the isotope and the smaller number is the atomic number.